Bismillah ar-Rahman ar-Rahim. In this video, I'm going to talk about how to find the eigenvalue of a matrix 2 by 2 and 3 by 3. So first, I have a matrix 2 by 2, which is this matrix is um, 3, the first row, 3, 6, and 5, 4. So lambda is eigenvalue of the matrix if and only if and only if A minus lambda I, the determinant, is equal to 0. So the question is how to find the determinant of A minus lambda I. So, see, A, I have this the matrix A. This is a 3, first row, 6, 5, 4, minus lambda I. What the I is? Identity 2 by 2. 2 by 2 is 1, 0, 0, 1. This is the I, 2 by 2. And if it is 3, will be 1, 0, 0, 0, 1, 0, 0, 0, 1, and so on if it is 4. The diagonal is 1, and the other entries will be 0. See, now, these two now. So how to find now the determinant of A minus lambda equal to? Now, 3 will be this, the first one is a 3, the first row, 6, and 5 for the second row. Minus what? Minus lambda multiplied by lambda, this identity 0, and this one 0. So equal to, now the matrix is A minus lambda I. We have 3 minus lambda, and 6 minus 0 is 6, 5 minus 0, 5, and 4 minus lambda. Now, the determinant of this one equal to 0. How to find the determinant? So the determinant of 3 minus lambda, and the 6 we have the second row 5 and 4 minus. So lambda is eigenvalue. Lambda is eigenvalue if the determinant equal to 0. So what is the determinant? So we multiply the diagonal 3 minus lambda times 4 minus lambda. So then we have here 3 minus lambda multiplied by 4 minus lambda minus the multiplication of 6 and 5, the product. So minus 30, equal to 0. So lambda eigenvalue if this one is a singular, this matrix and determinant equal to 0. Now 3 by 4 is 12. This is 12. 3 by lambda, negative 3 lambda. Lambda by 4, negative 4 lambda. Lambda by lambda is lambda squared. Lambda squared. Minus 30 equal to 0. So first lambda squared you have, and minus what? Minus 3 lambda, 4 lambda, 7 lambda. 7 lambda. And 12 minus 30 minus 18. Minus 8 equal to 0. To solve this equation by formula or by factoring, this can be solved by factoring. By factoring, so we have product 2 binomials. Lambda square is lambda times lambda. Positive, negative is negative. Negative, negative is positive. 18, 9 by 2 to get 7. So here I have 9 and 2, so it will be negative 7. Then the solution will be lambda 1, the first one, is equal to 9. And the second one, lambda 2, is equal to what? To negative 2. So this is the solution, negative 2. See, student, how to check the answer is correct? Let us to add lambda 1 plus lambda 2, if we add them. So then we have 9 plus negative 2 equal what? Equal 7. This sum is the sum of the diagonal. What's the diagonal? See, of the matrix diagonal 3 and 4. 3 plus 4, 7. 3 plus 4, 7. And here, what are the sum of two eigenvalues? 7. If not, that is mean we have a mistake. This is an incorrect mistake. So how to check now? We add them. First, second, multiply them. If you multiply lambda 1 times lambda 2 equal what? 9 times negative 2 equal negative. Now this one number is the sum of the determinant of the main matrix of matrix A. What is the determinant of this one? And to find the determinant of 3, 6, 5, 4. What is the determinant? 3 by 4 is 12. Minus 5 by 6, 30, 30. So 12 minus 30 is equal to what? Is equal to negative 18, which is the sum of the product. And now what the second condition you have? The product equal to what? Negative 18, which is the sum of what? The determinant of the matrix. If not, we have Now this example number one. Example number two. What example number two? Let me this one. I have to write it down. This one. Example two. So this one here. So write it this one. Example two. I write it down. Okay. Okay. Now the second best matrix is again we have a. This is a minus what is it? A minus lambda. Now equal what? We have 6 minus lambda and 2 minus 0, 2, 1 minus 0, 0, 7 minus lambda. This one is the matrix A minus lambda. As before, as above the first example. Determinant, lambda is eigenvalue if the determinant equal to 0. Now, what's the determinant of 6 minus lambda 2 and the second we have 7 minus lambda equal to 0. So lambda is eigenvalue. What the determinant of 6 minus lambda and a minus lambda I? Multiplication this by this one. So equal what? So is equal, we have here 6 minus lambda times 7 minus 10 minus define the determinant 2 by 2 minus 2 by 1 minus 2 by 1 is 2 equal to 0. So then the eigenvalue if equal to 0, this determinant is singular. And if this matrix is a singular. Now 6 by 7, 42. 6 by lambda minus 6 lambda is 42. And negative lambda by 7 minus 7 lambda. Lambda by lambda is lambda squared minus 2 equal to 0. First lambda squared I have here, and negative 13 lambda, because I have negative 6 minus 7, and 42 minus 2 is 40, plus 40 equal to 0. Now, then what you have now, this one also cancels by factoring, because 45.5, 5 by 8, or by quadratic formula. A quadratic formula, which is x equal or lambda x minus b plus minus b squared minus 4ac over 2a. So to find the x or here the lambda. Let's have the one. A is 1, b is negative 13, c is a plus 14. Okay. Or this can be solved by factoring. By factoring. So by factoring the product to binomial, I have lambda square is lambda lambda. And the sign is positive, negative, 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 positive, negative. 40 is 5 by 8. 8 times 5 equal to what? This one, 40, and negative 8 minus 5 is negative 13. So equal to what? Equal to 0. So now lambda 1 is equal to 8, and what about the lambda 2 is equal to 5, the solution. 8 at 5. If we add students here, lambda 1 to check the answer. I want now to check my answer correct or incorrect. Okay, to check my answer. Lambda 1 equal to what? Is equal to 8, and the plus lambda 2, I have to add lambda 1 plus lambda 2. Lambda 1 plus lambda 2 equal to what? Equal 8 plus 5, which is 13. 13. Look at here. The diagonal sum is 13. Here, 8, and what I said, and 5, 13. Yes. Now, where is the matrix? This is the matrix. This is our matrix, not this one. Okay. This is our matrix, the example. Now, 6 plus 7. 6 plus 7. 6 plus 7, what? 13. So 13, 6 plus 7, 13. And here we have lambda 1 plus lambda 2 is 13. Lambda plus lambda 2 is equal to 13. Is equal to 13. Now the multiplication. The multiplication. Lambda 1 times lambda 2. So what I have? I have 8 multiplied by 5, which is equal to what? 40. Now, what about the determinant of this one? See, determinant 6 times 7, 42, minus, I'm talking about the determinant of this matrix, and minus 2 by 1, which is 2, 40 minus 2. No, the determinant of this matrix 40, and the product of lambda 1, lambda 2, 40. In that, the answer is 100% correct. Why? Because the multiplication lambda 1 by lambda 2, 40, which is equal to what? To the determinant. And the sum equal to what? To the diagonal 30. So that now, again, the sum of eigenvalues equal to the sum of the elements of the diagonal. And the product of the eigenvalues equal to the determinant of even 2 by 2 or 3 by 2 or 4 by 4. Now, then, example, another example. Example number 3. example number. Okay, this example. Here, again, this one, a minus lambda I equal what you have. I have a 3 minus lambda, and the negative 6 only. This is negative 9, and this one 18 minus lambda. 18 minus lambda. Why? Because we have to find what we should have said. We have to find a minus lambda I. So what is the a? Here 3, negative 6, negative 9, 18, and I 1, 0. I mean here, this one is, and this one, what I have a 3, negative 9, okay, and here negative 6, 18, minus, what minus them, that times, what I is 1, 0, 0, 1. So then I lambda multiply, so here what I have, if I multiply by lambda, so equivalent, then I have to write here, lambda times 1 is lambda times 1, lambda, and times 0 is 0. Then we have 3 minus lambda is 3 minus lambda. Negative 6 minus 0, negative 6. Negative 9 minus 0, negative 9. And 18 minus lambda. Is okay. Now, this one is a minus lambda. And what we said, lambda is eigenvalue if what? If the determinant equal to 0. Now, let's have to find the determinant and put equal to 0. Okay, we have to put equal to 0. Now, how to find the determinant 2 by 2? Multiply this by this one. So then we have 3 minus lambda multiplied by 18 minus lambda minus multiplication this number by negative 6 by negative 9, which is 54 minus 54 equal what? Equal to 0. You have to put it equal to 0. So then the eigenvalue of this one equal to 0. I mean, this matrix is a singular. Singular means determinant equal to 0. This one singular, determinant equal to 0. A minus lambda, singular, determinant equal to 0. Now multiplication, 3 by 18 is 54. 3 by negative lambda, negative 3 lambda. And this by this one, negative 18 lambda. And lambda by lambda plus lambda squared minus 54 equal to 0. This one, 54 equal to what? Equal to 0. So first you have lambda squared and negative 18, negative 3 minus 21 lambda. And see this one, 54 minus 54 is 0. So then what they have equal to 0. This one is easy. Common factor. Take what I have to take. I take lambda common factor. So then what they have lambda minus 21 equal to 0. So then what they have lambda 1 is equal to 0 and lambda 2 equal to what? To 21. Now if we add them 0 plus 21 is now lambda 1 plus lambda 2 equal to what? 21. Now what about the sum? Look at here the sum. If I add 3 plus 18, 21. So the answer is good. Now, what about the determinant of this matrix? Determinant of this one. See, the determinant of this matrix, 3 times 18, 54, determinant, and minus negative 6 by 9, negative 9, 54. So the determinant is 0. Okay, here if we multiply lambda 1 by lambda 2, 0. Yes, lambda 1, 0 by lambda 2, 21. If I multiply lambda by lambda 2 equal to what? Equal to 0. So if you multiply them equal to 0 and equal to determinant of the matrix, and if you add them equal to the diagonal, the sum elements of the diagonal. Okay, then now example, if you have a 3 by 3, this is 3 by 3 matrix. Again, minus what I said, this is A. So what you have A minus lambda I. What the lambda I now? Minus what? Lambda. Now I, what is the I? The I is 3 by 3 identity matrix. And 1, 0, 0, 0, 1, 0, 0, 0, 1. This one A minus lambda equal what now? Will be equal to I have 8 minus lambda. First one, negative 6 minus 0. Why? Because lambda by 0, 0 will be negative 6. And 2 minus lambda by 0, 0. So it'll be 2 is the same. And negative 6 minus 0, lambda times 0, 0, so it'll be negative 6 here. And 7 minus this one, lambda times 1, lambda. 7 minus lambda. Negative 4 minus 0, because lambda by 0, 0, so it'll be negative 4. And 2 minus 0, and negative 4 minus 0, and 3 minus lambda, because lambda times 1 is lambda. Why? Because this one, what this one is, it'll be lambda 0, 0, 0, lambda 0, 0, 0, lambda. So what I say, 8 minus lambda, this one. Negative 6 minus 0, negative 6. 2 minus 0, negative, and so on. Okay, and so on. Okay, now, see. Now, this one, 3 minus 3 minus lambda. Now, again, this matrix, to find the eigenvalue of this matrix now, our lambda is the eigenvalue if and only if the determinant equal to 0. What means the determinant? So that of this matrix equal to 0, then the lambda be eigenvalues. Okay, that's how to find the determinant. How to find now the determinant of this one, of this matrix. To find the determinant. We have more than one method. So we can repeat the first two columns. So what the first column now I have here? See, I have here 8 minus lambda and negative 6 and 2. Second one is negative 6 and 7 minus lambda and minus 4. So to find the determinant, we multiply the elements of this one and this one and this one. Let's have to multiply them. So 8 minus, okay, 8 will be, see, will be 8 minus lambda multiplied by 7 minus lambda multiplied by 3 minus lambda. Okay, plus multiplication of this one, 4 by 6, 24, 48. And the plus what I have 2 by negative 6 by negative 4, also 48, because this one 12 and 40. Now this one first multiply, multiplication, okay, minus, what minus? The multiplication also. Which one now? The multiplication of this one. Yeah, see this one. Negative 6 by negative 6 by this one. So what I have, negative 6 by, it will be 36. 36, okay. Negative 6 by negative 36. Multiply by 3 minus lambda. Plus the multiplication of the diagonal, of this diagonal. This one. So what I have 8 minus lambda by negative 4, 16. So this 16 times 8 minus lambda. And the multiplication of this one, this diagonal, 2 by 2, 4, plus 4, multiplied by 7 minus lambda. This is the determinant. And you have to put this determinant equal to what? Equal to 0. So lambda is eigenvalue, and the determinant equal to 0. Now we have to simplify this one to find the determinant. To find the determinant, you have this one is 8. The first one is 8 minus lambda multiplied by, this is the multiplication of this one. Lambda by lambda is lambda squared, and negative 3 lambda and negative 7 lambda and negative 10 lambda I have here. And 3 by 7 is 21 plus 21. And 48 plus 48 plus 96. So I have under here multiplication, lambda by lambda will be negative lambda cube. And square 8 lambda squared, and 10 by negative 110. We have here 10, so we plus 18. Lambda squared, and lambda negative lambda by 21, negative 21 lambda, and negative 80, negative 101. 80, and this is 21. Yes, 101. So I have here negative 101 lambda, and then 8 by 21, the last one, plus 20, 160, 160, 168. 168. This is the multiplication. So if you see what I said, lambda by square lambda cube, and to get square lambda squared by 8 lambda squared, and negative 10 lambda by negative 1 here, negative 10 by negative 8, negative this one. I have here 80. This one, just I have to correct this one again. Lambda cube and squared, how to get squared? This by this one, 8, and this one by this one, 10. It is correct, 18. And about the lambda, negative 21 and negative 80. 80 will be 101. Yes, here there is 1. Here 1 is missing. So 101, because I have here lambda by 21 by negative would be negative 21 lambda, and this one negative 80. Yes, negative under root 1 lambda. I said negative under 1, but I put it 10. Any mistake will be not the same solution. Then 8 by 21 will be 168 plus 96. Now it's okay. Now it is okay. This is the multiplication. Then what we have, minus, we have here minus what? Minus. Now this multiplication, now this is done here. Now minus this one. I have 36 by 3 is 180, 90 and 8 will be 108. And 36 lambda. And 16 by 8 is 80 and 48, 128. And 6 by this one minus 18 lambda. 16 lambda, sorry. 16 by 16 lambda. And 4 by 7 is 28. And 4 by negative lambda, negative 4 lambda. Equal to what? Equal to 0. Equal to 0. This one is equal to 0. Then, so then what I have this one, now this one, the first one, minus, here minus what? Minus the second one. What the second one is? I have the second one, this one, then the C 108 and 128. And here I have 28, 20 and 28. If I add 28 with the 28 will be 56, 156. 156 and 256 and 8 will be 264. 264, this one, and this one, and this one, 264. Yes, 264. And here there is 264, and we have lambda. With lambda, I have 36 and 16 will be 52, 52 and 56. So that will be minus 56 lambda. Okay, 56. But here 96, add 96. This one I have to add here 96 to this one, because this one I said 18 by 160, but the plus 96. I didn't put this one plus 96. Okay, so here I have a plus 96. Now, okay, now this one minus this one. Okay, this is the first minus equal to what? Equal to 0. So what we have now? We have here minus lambda q plus 18 lambda squared minus 101 or minus 56. This one is minus 100. This one is minus 56. So minus we have, but the plus, this is plus, negative is positive. So it will be 460, 45. 45 lambda. Yes. So this one minus 101 lambda minus 56 and we plus 56. And I have negative 101 lambda plus 56 lambda. So then what equal negative 45 lambda. Yes. And then this number 1, I have 68 plus 96 will be 200. This one 64, 264. And minus on this one with this one will be 0. So equal to what? Equal to 0. Okay, equal to 0. So this is lambda. This one is lambda. Yeah. Yes. Now, negative lambda is common factor. I can take negative lambda as common factor. So I have lambda squared plus 18 plus 18 lambda minus 18 lambda minus 18 lambda. This one minus 18 lambda, and I have a plus this one 45. Yes, plus 45 equal to 0. So now what I have lambda 1 is equal to 0, which is this one, the first one is the first one, equal to 0. Or what? Or this one, what's this one is lambda squared minus 18 lambda plus 45 equal to 0. Now this one by quadratic formula or factoring. Factoring 45, 15 by 3. 15 by 3 will be 18 here I have. And multiplication 45. So with this lambda minus, and here I have lambda, negative, positive, negative. And 45 is 15 by what? By 3. See, then what I have lambda 1 is equal to 0, and lambda 2 is equal to 15, and they have lambda 3 is equal to 3. So we have now the first one is 0. The first one is 0. The second one is 15. And the third one is 3. If we add them, 3 plus 15, 18. Plus 0, 18. Let us to add the diagonal. What about the diagonal? 8 plus 7, 15. Plus 3, 18. So 8 plus 7 plus 3, 18, which is equal to what? Equal to the sum of lambda 1 plus lambda 2 plus lambda. See, lambda 1 plus lambda 2 plus lambda 3, 0 plus 15 plus 3 equal to what? 18, which is the same of this one. This way you can check the answer. And see the multiplication, if we multiply here, lambda 1 times lambda 2 times lambda 3 will be 0. That is mean the determinant of this one, 0. This one you can check it. The same way you can check, students. You can check that. Now, if I return back to example number 1, this example. What about the inverse of this one? This is A. See, students. A, what is the A? A is the 3, 6, 5, 4. A is what do you have? A is 3, 6, 3, 6, and 5, 4, 5, 4. 3, 6, and 5, 4. Yes. So the inverse, A inverse of this one. How to find the inverse? The inverse determined here 12 by 30 minus 30. So we have minus 18. So be 1 over negative 18 multiplied by here. What I have here? This one 4, cancel, adjoin of this matrix. And this one 6 will be here 5, negative 5. And this one will be negative 6. Okay, and this one is 3. Okay, so the transpose of this one, so be 1 over negative 18 multiplied by, here you have 4, negative 5, negative 6. 3 is the inverse of this one. What about the determinant of this one? Will be equal to what? The eigenvalue often. The eigenvalue of this one, of the inverse. The eigenvalue, what is the eigenvalue of A? The eigenvalues of A. Here, what we said? We said 9 and negative 2. So what about the eigenvalues of the inverse? Will be the eigenvalue of A inverse will be 1 over 9 and 1 over negative 2. So the lambda of eigenvalue of A, then lambda or negative 1 over lambda is the eigenvalue of what? Of A inverse. Now this one I leave it to you to prove, to find the eigenvalue of this one. So it will be 1 over 9 and 1 over negative